You know that AI is something really explosive these days, and 5 to 10 years ago we have to drive car, but now the car is driven itself. Or maybe in the parking lot, we don't have to write the license plate on a paper anymore. With just a camera, anything can be automatically. But what about education, a field that can influence and can have a huge impact on the future of the human? It hasn't changed for over 100 years, almost hasn't changed. The second is wasted. Teachers have to spend too much time on paperwork that is not related to education. For example, like making the wrong call, updating score, and overload. So in Vietnam, on average, a secondary school teacher have to update score for around 2,000 test papers per semester. So imagine with the amount of time we have to open the Excel file, we have to control F to find a student to update for each student, and with that time, maybe it will affect our health and lead to the incorrect update. So it leads to the automated scoring system. So the system will have three main steps. The first step is after the grading, the teacher will put the test paper here under the camera, under the phone camera, and then the laptop will take the image to extract and recognize three information, that is the name, the student ID, the student identification, and the score. So this test paper is the test paper of my university, Ho Chi Minh City University of Technology. And finally, it updates the score into the class list in Excel file. The background principles. So here, text detection, I have compared between IST detector and scale space technique. IST is like deep learning technique. So it have two main stages. The first stage is fully convolutional network, where they will have the output is the probability of the text and the location of the text. And the second stage is non-max suppression to sum the bounding box into one last final text box. The scale-based technique is like image processing technique. I have three main steps. The first step is line segmentation, and maybe we can remove the horizontal or vertical line of the paper. The second is we make the blob light feature right here with Gaussian filter and maybe blurring. And finally, we use the criteria of the width-height ratio or maybe area to segment the words. Text recognition model, I use CRNN with CTC loss function. CRNN is the combination of CNN, which is really good with image feature extracting without affected by rotating or scaling. RNN is really good with series data like music, the text or something, because they can use the previous character, the previous information to update for the current information. And final is the transcription layer here. They will convert the matrix output of RNN into the final text. CTC loss function. The advantage of it is it reduces the cost, the expense and the manual labor to label every character and the time step. We just have with CTC loss, we just need to label the word and the image of the word. Encoding. Encode here is they create correct alignments of ground truth. For example, for the sun here, they have blank space and maybe double the character right here to make the right alignments. And the objective is to maximize the probability of the sun of the output matrix of RNN. And the probability of the sun here is the sum of the probability of all the alignments here. decode, we have a lot of techniques like the word beam search, greedy search, prefix, but the common idea is to remove the blank space or maybe just some the double character here into one character. The results. So this is the flowchart of training and recognizing handwritten text. We have two main phases, the train phase and the test phase, but they have three common steps. The first step is image processing, like blurring, Gaussian filter, rotating, scaling to the right position. Second is text detection. It's usually include the word segmentation. And finally, we extract the feature, image feature, and recognize them. It means we convert the image matrix into ASCII code for the computer to understand. Image preprocessing. So the input image will include two main information. The first information is the test paper, and the second is the background information like desk. And furthermore, the test paper is not in the right angle for recognition. Here I have image alignment technique. Is the I would compare uh, I would compare the input image to the sample with the corner, the edge, and the right image. Here is the result of image alignment technique. After that, I grayscale and blurring to remove noise. And here we will identify the biggest rectangular right here with drawing contour with criteria like the contour here must have four edges and the criteria of width and height ratio and the area criteria. So after we draw the contour and identify the coordinate of x and y here, we can move the fixed pixels to extract three main information, that is score, name, and student ID right here. So text detection, I compare ist and scale space. So the first glance is the result of is wrong. Ist can just extract 2 out of 3 words, but scale space is right. The ist is deep learning technique, so it's slower, complex, and requires stronger laptop. So my laptop is not able to run ist in real time, but scale space it more suitable with the system and with my laptop. Furthermore, it have to resize the original image to the multitude of 32. Like the original size is 55, 550. We have to resize it into 64 and 576. But in this project, I will use the scale space technique. Here you can see some blurring image, and after the threshold it can lead to the bad results. Here I will increase contrast with top hat and black hat transform. You can see the result is much better right here. And the threshold, adaptive threshold, is really good with the image, the big image, and non-uniform lighting by calculating a lot of threshold on one image. So the image will be separated into grid, and they will calculate the threshold T on each grid. So that's why they can tackle with non-uniform lighting. But you can see that after using adaptive threshold, we get a lot of noise. This picture here is after I use the blurring tool, but they retain a lot of noise, and you can see that the horizontal line here is really hard to word segment correctly. But also threshold right here, they're good. They're not really remain a lot of noise, but you can see that the stroke is thinner. But also is good in this project because the image after extract is really tiny compared to the original image. So the non-uniform lighting is not really a problem in this case. So I use also threshold for this project. So after that, I remove the horizontal line and remove the circle here of the score and remove noise, and we have the final result. Name, student ID, and the score right here is really good result. The model structure and training phase. I use two model structures for two tasks. The first task is to recognize the words, which mean the name, and the second model for recognizing the numbers, which is the student ID and the score. The input image would be standardized, normalized, transposed, and padding to fixed size 128 and 32 pixels to feed into the CNN of VGG16. We have convolutional max pooling and batch normalization layer, and then they feed into attention layer. Attention layer is like an upgrade of LSTM to increase the recognition performance. Here I use by LSTM. So why by LSTM and not RNN? Because RNN we have some drawbacks with exploding gradient and vanishing gradient. You know, that's just short-term memory. But LSTM is long short-term memory. They can remain the information from far away. The term by here is bidirectional, which means they can use the previous character and subsequent character to update for the current character. The transcript layer here I use the word beam search with the lexicon search. The lexicon search is the dictionary of is the search through the dictionary of the class list. Some more tricks I used is data augmentation, changing learning rates with epochs, and early stopping. Evaluation on 122 images dataset. So it includes 122 text image of just one information, that is my name and my student ID and one score right here, with 122 different backgrounds, camera angles, and lighting to evaluate name and student IDs with the changes in the image pre-processing stages and the changes on the model. So here I use the index, the character error rate, and the word error rate, and lexicon search on the class list of 245 students. So as you can see that the first three, this is the result of name recognition. So as you can see that the first three columns here, we have the result is pretty good. But attention here, we can say that the CER is decreased a little bit, which is good, but the WER is increasing, which is not good. But why did I use attention? I recognize that if the model without the attention, if it right, it can be really right, like 100%. But if it's wrong, it can really wrong, like 20 to 30%. But with attention, attention is like a mean calculation technique. So when it's right, it's not really at right. It's like 80 to 90% right. But when it's wrong, it remain enough information for the lexicon search right here to have the good result. So the result with attention is below 1%, but the result without attention is about 2 to 3%. So the results of student ID recognition. Here in student ID recognition, I use the best model here, but I change the way I create data. So you can see the first three columns is I create data from the MNIST dataset, 7-digit number or variable length of number, or maybe rotate scale. Each number, we can see that the WER is still 100%, which is really bad. But then I realized that the image from the MNIST data have the size, the fixed size 28 28 pixels, but so they have a large edge, so we have to shorten the distance between the digits. And then I use scale and rotate on the whole image. We got a good result. Then I add real data, about 800 images, which include 250 images is like a number with variable length. It's for student ID recognition, and 550 images remain is for score. It's like 1.25, 7.8, maybe it's the images. So the lexicon search is quite good. But if we lexicon search with a format of name and student ID at the same time, we can get CER and WER is equal to 0%, which is the accuracy is 100% in finding the index of the student. So evaluation on 100 unconstrained images. Unconstrained mean unconstrained about the font type, font size, and spacing between the word, between the number. The number here can out of the circle limitation. It for evaluating the name, student ID, and score recognition under the bad condition. So you can see the result here. I will move on. The name, student ID, that is the index of recognition on 100 unconstrained images. You can see the result right here is quite good. So common mistakes are the font type is not in data train. So you can see the first character of each word here is not in the data train. The wrong word segmentation or the similarity of the information, like this information and this information, it's just different for two characters. The number 2 here, number 3 here, the U here, and the A here. For the score recognition, you can see the result here is not really good. With this result, we can use it in real life. So some of the mistakes are because of the user. Number 5 right here is out of the circle limitation, so it is gone. Here is because of the blurring image leads to the information lost after the threshold. So as I said before, we can fix that with increasing contrast with top hat and black hat transform. Incorrect image crop. This is because of the image alignment technique is wrong. So we can fix that by increasing the number of the feature comparison between the input image and the sample. The contour drawing error right here. So you can see that the circle is really nearby the number 1, so it lost. And some of the common mistake, but they are mainly because of the user. Like the comma right here make the 0 is like 9, or number 3 right here, and number 5 and horizontal or vertical line right here is it's really a bad handwritten text, so it's really hard for the model to understand. So I create another set to which remove the user errors to evaluate the model better. So evaluation on the 103 constrained images. Constraint is the constraint about the font type, font size, and spacing. And background, camera angles, and lighting. You can see that the sample right here. The word is clean, number is clean, and the number here is not allowed to out of the circle limitation. Okay, so you can see that student index, the name and student ID right here. The result of 103 constrained images is better than the 100 unconstrained set. And the number right here, you can see it. For the score, it's really good. Okay, it's really good. I will go through the results. So evaluation on video. So the real system is not like recognizing on each image. It's different. Like for name and student ID, you can have lexicon search, you can have class list to support for the accuracy of them. But the score, you don't have anything to supported to increase the accuracy of the score. But with video, we got a lot of frame, continuously frame, so we can. So I use this criteria. If we recognize score and student index are the same for 3 consecutive times, it will update the score into class list, and it will raise the accuracy so much. So I can use a lot more criteria with the image pre-processing. Like you remember the biggest rectangular, okay? So we can use criteria of the edge, of the area of the ratio, or maybe use the criteria of the name and student ID recognized. So if the output of the model and the output in the class list are similar, we retain the information. But if they are really different, we will eliminate the picture, eliminate the result. So the final accuracy is about 95.55%. 43 out of 45 test paper correctly updated. So so let's move to the demo of my system.
Hello everyone, so this is the demo of my automatic scoring system. So after the teacher scoring on the test paper, they put the test paper under the camera. As you can see that the camera is about 15 to 20 centimeters above the desk, and see the light condition is quite good. Okay, so the image of the test paper will be transmitted into the phone's camera and then transmitted into the web server. And then the laptop will download the image from web server to pre-process, to recognize and upload into Excel file. So this is the my phone screen. You can see this IP webcam right here. And now let's see some setting of that. Okay, video. I use the main camera, primary camera. The photo resolution here is 1920 multiply 1080 pixels. The quality is 63. No flip, frame per second 20. And on flash mode default, if the light is dark, you can use the flashlight to increase the recognition performance. Okay, so here I click on start server. You can see that the address of you can see the picture of the test paper.
So this is my laptop screen. So as you can see that the IP webcam here, they create for us a web server with address that 192 port A0A0. As you can see, this is the picture, no video browser. Okay, so the address of here, we can take the address at copy image link right here. And yes, this is the Visual Studio Code. So if we run the program, you can see that the graphic user interface right here, this is my thesis defense with the logo of my university. You can see that the video URL, so we can paste the web server address. This is the class list. You can browse file right here. So we have the class list right here. As you can see, the class list have student ID, the name, and the score. This column is for it's for us to easy to know that the recognition is true or false, and this is the predict score of the system. So you can see that there's no score. There's no score here. First, okay, there's no call. Let's save it. So let's turn it off. And okay. Okay, now the user can browse files. We choose the class list here is the class list that we want to update the score on. So open. So after that, every information is up here. So let's start recognizing. Okay, after click the start, you can see that the image. Okay, the score is updated for 1710.725.4.5, and here another score 1710.286.1.5. 986. Okay, that's good. Okay, that's good. So the system will save the information after I click save here. So let's see the classes again. So as you can see that they haven't updated any score, but after I click the button, okay, I just want to okay, I want to add more paper for you to understand. 5183347. Okay, that's good too. So after I click save, okay, so the index confirmed and the score confirmed here is for the update the score. So click class list again. So you can see that the score 555.25 is good. Okay, 4.5, 1.5 here. So the accuracy is 100%. That's good, right? Okay, let's see solution. Okay, you can see right here is the machine. Okay, you can see here is the machine record the name and the student ID and score of every time. But if the name, the student ID and score is 3 consecutively recognizing the same, they will update the score into the system. Right here you can see that 1, 2, 3. Okay, so here is 1, 2, 3. That's good. Here's 1, 2, 3, 4. Okay, you can see that 1, 2, 3, 4 as 3 times. Okay, so that's the demo.